Super atom.
Before we get going into our adventure, we need to know what is exactly nuclear physics. Nuclear physics is the study of the atomic nuclei and its interactions. Before we start with our adventure with superatom and nuclear physics, we need to learn more about the nucleus and its composition. So as we can see here, we can see the electrons that orbit around the nucleus, and the nucleus that is the most dense part of the atom and holds about 99.99% of the mass of the atom. Now let's go deeper into the atom. The nucleus of any atom consists of protons and neutrons. Protons are positively charged, while neutrons are electrically neutral. Both protons and neutrons have relatively the same mass, and because they are both found in the nucleus, we call them nucleons. We have two types of transmutation, artificial transmutation and natural transmutation. And from the names, you could tell that artificial transmutation happens from a factor from the outside, while natural transmutation happens without any help from the outside. Radioactivity is the spontaneous emission of radiation by unstable nuclei to become stable. It attains stability by the emission of alpha particles, beta particles, or gamma rays. Now let's talk a little bit about these different radiations. First, we have the alpha particles. Alpha particles have a really low penetrating power, which can be stopped by 7 centimeters of air or a piece of paper. Alpha particles are the nuclei of the helium atom, having 2 protons and 2 neutrons. If entered into the body, alpha particles would be really hard to get out, and they cause really major mutations in the DNA genes and the cells of the body. In alpha decay, a helium nuclei is produced, and the atomic number is decreased by 2, while the atomic mass is decreased by 4. Now, after we're done with alpha particles, let's talk about beta particles. Beta particles are very high-speed electrons or positrons that are ejected during a nuclear decay, called beta decay, which occurs when a nuclei has too many neutrons and wants to achieve stability. Beta particles are less ionizing than alpha particles, which means they would do less damage. Getting exposed to beta particles can cause burn like severe burns, and they have higher penetrating power, meaning they could easily penetrate into the skin. They can be easily stopped by an aluminum plate or a sheet of plastic. In beta decay, a neutron decays into a proton, emitting an electron and an antineutrino. The atomic number increases by 1, while the atomic mass stays the same. Now, after we're done with beta particles, we can now move to gamma rays. Gamma rays have no mass or electric charge, so that they can move in their speed of light. They would need to travel thousands of meters in air to spend all of their energy. Gamma rays have very high penetrating power. Simple normal gear clothes for air shielding would not be protective enough. You would need to have really thick steel or concrete or lead to be able to stop gamma rays. Gamma decay occurs when some unstable atomic nuclei releases excess energy by a spontaneous electromagnetic process. In this process, gamma rays, which are photons or packets of electromagnetic energy, are radiated. As you saw from the decades that we saw above, you can see that the atom before going through nuclear decay was called parent atom, while the atom after it went through nuclear decay, it was called a daughter atom. Now, let's go to artificial transmutation. Artificial transmutation is the conversion of one element into another by artificial means. This means, for example, a scientist would bombard an atom with a particle like alpha particles or a neutron to form a new element. We have two types of artificial transmutation: fission and fusion. Fission occurs when a neutron hits a larger atom, forcing it to split into two smaller atoms. This process could cause also additional neutrons to release that would initiate a chain reaction. When this atom splits, a tremendous amount of energy is released. Chain reaction is when neutrons released from a fission process hit other atoms and causes them to also undergo fission.